Nick Chambers. This is for Dr. Thomas. I'm wondering about your cost of the hydrogen stations for the steam methane reformers. That's a pretty impressive number. Does that include storage on site or environmental impact assessments, anything like that?
Remember, I had two numbers. One was the number of production, and then below that I had the number that included compression and storage. So that was the, what, 850? I don't remember the numbers.
Okay. And what about environmental impact assessment?
I don't know.
Yeah.
No, that's strictly the production cost. And making a 10% real after-tax return on the investment for the station owner, buying the SMR, the compressor, and the storage.
Mm-hmm. The reason I ask is because, electrical charging infrastructure doesn't require environmental impact assessments to install. So
Okay.
it's a fair question, I guess. The next question I have really has to do with your emissions comparisons. When you're talking about making hydrogen from natural gas, are you including the emissions from mining that natural gas and then transporting it, or is that just a pure the chemical process itself?
No, I apologize. I should have put it on the slides too. All the data we have are based on the Argonne GREET model, which is kind of the gold standard in this business, looking at the full well-to-wheels greenhouse gas emissions as well as the local air pollutants. So all those numbers were generated from the GREET model. Now, like all models, it depends on what your inputs in are to the model, and those can be questioned. But no, as I say, they were all based on full well-to-wheels analyses.
Okay, thanks.
And actually, the one chart I showed you, the busy chart with the gasoline vehicle and the battery electric vehicle on the right, that is an Argonne chart.
Professor Weimer, that Daggett facility in the desert, the solar facility, I wasn't clear on how many vehicles could be served by a facility of that enormous size.
So we were looking at a facility to make 100,000 kilograms of hydrogen a day. And a hydrogen fuel cell vehicle would get roughly 400 miles of range, I think, on about 5 kilograms of hydrogen as a typical value. And so you could do that calculation and figure that out.
You don't know what it is offhand, though.
It's 15,773.
There you go.
15,773 what?
Vehicles on 100,000 miles a day based on the Toyota fuel cell vehicle at 68 miles per kilogram.
Dr. Thomas, if consumers won't embrace natural gas, why would they embrace hydrogen?
Good question. I'm glad you brought that up. I know the gentleman this morning was promoting natural gas vehicles. It turns out if you look at the numbers, and it's on my webpage if you're interested, but if I have 100 gigajoules of natural gas, what's better? To make electricity out of the natural gas to run a battery electric vehicle, to make hydrogen out of the natural gas to run a fuel cell vehicle, or to put the natural gas into a natural gas vehicle. And it turns out it's far superior on cost as well as greenhouse gas emissions basis to make hydrogen, because I can make hydrogen at about 75% efficiency. And of course the fuel cell vehicle is anywhere from 2 to 3 times more fuel efficient than a regular car. Of course, by the way, a lot of people say, why would you make hydrogen from natural gas? Because there's more energy in the natural gas than is in the hydrogen. You lose energy, of course, but that's true of all fuels. Gasoline has less energy than what went into the refinery. The worst offender is electricity.
Right, but you can't run cars on crude oil. You can run cars on natural gas. So
I can run a fuel cell vehicle on hydrogen too.
I understand, but but why wouldn't it make more sense to run it from the base fuel, natural gas, instead of hydrogen?
Because it's much more efficient to make the hydrogen to go into the higher efficiency vehicle. As a matter of fact, if you look at the numbers, I can go, if I take, whatever X kilojoules of natural gas, I can go anywhere from 1.2 to 2.4 times farther in a fuel cell vehicle than I can in a natural gas vehicle.
Does your natural gas vehicle, does it have a combustion process, a ICE engine or a fuel cell?
Or it has to be ICE.
Well, I'm asking the gentleman who's asking the question. So it's just important that you understand the natural gas would be with an ICE and the hydrogen would be with a fuel cell power plant. Do we understand?
That's why, because
the
efficiency of the fuel cell.
Correct.
Primarily.
And then you would add to that, of course, the environmental impacts relative of the two, but you just have to appreciate that the fuel cell is substantially more efficient than the ICE engine, and that offsets some of the inefficiencies in generating the hydrogen.
Have I got it right that if you burn a quantity of hydrogen or you run it through a fuel cell, that you're extracting about double the energy in the non-combustion reaction in the fuel cell than you would be by burning that hydrogen, and that's one of the big strengths of fuel cells.
Absolutely. And of course, you also have zero local air pollution with the fuel cell vehicle, whereas a natural gas vehicle has a lot of criteria pollutants that would concern particularly people in Southern California.
I was waiting for the air quality to come in on that
Yeah.
discussion, so very good.
Tom Bartley Ideas. I formerly used to work at ISE, who is probably the largest hydrogen fuel cell bus manufacturer in the world now. Very exclusive market, very few really buyers or vehicles out there. But in any case, one of the things they looked at was hydrogen in a fuel cell versus hydrogen in an internal combustion engine based on the Ford V10. And your statement about you can be twice as efficient in a fuel cell as you can in internal combustion, what happens is if you're using hydrogen in an internal combustion engine, you can get far higher efficiencies than if you're using any other fuel. So that statement is not quite correct.
No, I was referring to a regular gasoline-powered car versus a hydrogen-powered fuel cell vehicle. And you're right, if you go to real high compression ratios and lean burn, you can get higher efficiency out of the fuel cell, internal combustion engine running on hydrogen. That's true. But if you look at the ordinary car that's on the road today, a gasoline-powered internal combustion engine with low compression ratio and so on, versus a fuel cell, hydrogen in a fuel cell. As a matter of fact, the Toyota Highlander non-hybrid gets about 22 miles per gallon by EPA ratings. The fuel cell version that you can drive today or tomorrow is about 69 miles per gallon, so it's more than 3 times as fuel efficient. So you got an example right out here in the parking lot of it's actually 3.2 times higher efficiency.
I certainly agree to that, yes.
Okay.
But you got to be careful when you compare one with the other in choosing the fuel.
Jorge Kecklin, did I hear correctly that 10% of the fuel stations, when you show that map of Long Beach, 10% of the fuel stations will serve the equal amount of hydrogen cars?
That's what I stated. We'll serve the same population of vehicles, yes.
10% of the fuel stations will
10
be
10%.
of what it is there today. And I just have another question, just in case. I've heard that the Wankel engine, the Wankel rotary engine, is a perfect engine for hydrogen, yes?
Yes. And so Mazda has deployed a hydrogen Wankel product in Japan and is considering deployment here in the United States as well. Combustion Wankel.
Thank you very much. I think that was a great discussion. I'd like to thank our panelists one more time.